Horizontal surface ocean current. The flow on the surface of the ocean moves only 10% of the oceanic water. The surface flow is considered up to 500 meters of depth. The discharge of water in the oceans is measured in Sverdrup unit. It is equivalent to 1 million cubic meter per second discharge. The horizontal flow of ocean water occurs as warm and cold currents. These currents flow from the equator to the poles and from the poles to the equator. As you know that towards the equator it is very hot, which results to warm currents, and it is cold towards the poles, which results to cold currents. Because of this difference in temperature, the warm current flows from the equator and cold current flows from the poles. These currents are pushed to long distances by the planetary winds. As a result, the ocean water flow from equator to both the poles and vice versa. You have studied the map given in 5.4 earlier. We have studied that ocean currents are formed due to differences in temperature, density, and planetary winds. In addition, the following reasons are also responsible for the direction of flow of ocean currents and their velocity. Rotation of the earth. Because of the rotation of the earth, the ocean currents move in clockwise direction in the northern hemisphere and in anti-clockwise direction in the southern hemisphere. This is known as the Coriolis effect. If the earth did not rotate and remained stationary, the atmosphere would circulate between the poles, that is high pressure areas, and the equator, that is a low pressure area, in a simple back and forth pattern. But because the earth rotates, circulating air is deflected. Instead of circulating in a straight pattern, the air deflects toward the right in the northern hemisphere and towards the left in the southern hemisphere, resulting in curved paths. This deflection is called the Coriolis effect. It is named after the French mathematician Gaspard Gustave de Coriolis, 1792 to 1843, who studied the transfer of energy in rotating systems like water wheels. Continental structure. According to the alignment of the coastline, the direction of the ocean current changes. The velocity of the ocean currents is around 2 to 10 km per hour. The ocean currents are divided into two types: cold currents and warm currents. Do you know the ocean currents of the Indian Ocean? There is similarity between the patterns of the ocean currents of the Pacific and Atlantic Ocean, but the flow of the ocean currents of the Indian Ocean are different. The Indian Ocean is landlocked in the north. The equator divides this ocean into two parts, northern and southern. The monsoon winds influence this ocean tremendously. These winds change their direction according to the season. In the northern part of the Indian Ocean, currents flow in clockwise direction in summer, while in winter they flow in the opposite direction due to reversal of monsoon winds. Effects of ocean surface currents on human life. Ocean currents especially affect the climate of the regions having proximity to the sea, which means that the regions which are closer to the sea are highly affected. In cold regions where warm ocean currents flow, climate becomes warmer. In some regions, the amount of precipitation increases. For example, the warm ocean currents flow near Western Europe, southern Alaska, and Japanese coast, reduce the intensity of the winters there, and make them warmer. As a result, these ports do not freeze in winters. Had ocean currents been absent, the ocean water would have remained still. In such waters, the biotic components would have been devoid of food, or there would be no kind of food, or any kind of food. Consequently, marine life and its ecosystems would have been limited in its extent. In regions where cold and warm currents meet, plankton, vegetation, algae, etc. grow. This is food for the fish. Therefore, fish come here in large numbers and breed. That means fishes come here in large numbers and they breed, that is, they multiply. Okay? This has in turn led to formation of large fishing grounds. Grand Bank near the North American coast in Atlantic Ocean and Dogger Bank near the European coast are some of the examples. With respect to the water transport too, the ocean currents are very important. If the transportation is done according to the flow of ocean currents, the speed of the ships increase and the fuel is saved too. Near the coasts where cold currents flow, the amount of precipitation is low. For example, in Peru, Chile, and the arid desert of southwest Africa, at places where the cold and the warm currents meet, thick fog is formed. Such fogs create problems for transportation. The warm Gulf Stream and the cold Labrador currents meet near the Newfoundland Island. This leads to dense fog. Because of the cold currents, icebergs are carried away from the polar areas. If such icebergs come along the marine routes, they are hazardous to the ships. Now, as you see here, that icebergs can have an adverse effect with regards to transportation or with regards to the marine routes. Okay, if icebergs come in contact with the ships, they will crash into it and it will cause an inconvenience for the travelers to travel across the sea.